Greetings and thank you for watching the Linux System Administration live lessons. My name is Ben Whaley and I'm a professional Linux system administrator. I use Linux to power the cloud-based web systems for Anki, a consumer robotics and artificial intelligence company based in San Francisco. I'm the co-author of the Unix and Linux System Administration Handbook from which the contents of these video lessons are based. When I started administering Linux systems for a small computer services company in 1999, the world was only beginning to understand the deep impact that the internet would have on our daily lives. I was mesmerized by the dynamism of the consumer internet experience, and yet even more fascinated by its flexible and powerful underpinnings. Linux provided the perfect conduit for me as a tool to learn operating systems, networking, and the internet. System administration is a respected discipline needed at organizations of all shapes and sizes. In a small business, the administrator may run only a few Linux servers that coordinate the internal network. At an internet technology company, Linux is often the critical infrastructure on which the business and its products or services are built. At a hospital, Linux might run medical and clinical software, administrative systems, and research labs. In all cases, the administrator is responsible for keeping the systems running smoothly and for meeting the business's technology objectives. Administrators should be communicative, curious, and diligent. Organizations depend on administrators to be the steward of its systems, and as such, administrators should freely discuss concerns and desires about the system's environment, opportunities for improvement, and mistakes made. New tools and technologies should be carefully explored and embraced when appropriate. Administrator diligence may be the difference between a company that values the security of its customers' data and one that exposes it. The line between software development and system administration is increasingly blurry, particularly with the prevalence of programmable cloud systems. Repetitive tasks on computers, such as installing operating systems and configuring software, are nearly always avoidable through automation. Administrators shouldn't be afraid of learning how to write software to automate these manual tasks. I prefer to learn the configuration of an unfamiliar software package by first installing it manually, and then use code to automate the installation for future use. The saying in the industry is, automate or be automated. In this video series, we'll explore the fundamentals of maintaining and administering modern Linux systems. Lessons will be a mix of conceptual content followed by examples and command line demonstrations. Most of the examples are based on the CentOS distribution, a Red Hat Linux derivative used by many businesses. Each lesson will use the teachings of previous lessons to demonstrate the power and utility of the command line. I encourage you to use the Unix and Linux System Administration Handbook as a text reference to this video, and to rewind and rewatch any sections that move quickly. You'll notice that I make extensive use of shell shortcuts and tricks throughout the video. Learning these techniques will impress your friends and colleagues and improve your efficiency on the command line. This live lesson comprises 9 lessons on Linux system administration. In Lesson 1, we'll get started by understanding the basic duties of a system administrator. I'll introduce 2 tools, Vagrant and VirtualBox, that you can use to experiment with Linux. I'll also point you to additional documentation and resources for learning Linux. In the second lesson, we'll discuss the Linux shell. We'll learn how a Linux system is organized and how to use the shell to navigate the system. We'll also touch on scripting languages that can be used to automate common administrative tasks. Lesson 3 is about the startup and shutdown procedures of a Linux system. We'll cover the material at a conceptual level before we dive into the details of the Linux initialization process. In Lesson 4, we'll learn about controlling access to the system. The administrator is the go-to person for controlling who has access to what, so understanding this material will be useful. We'll cover what happens when users log into the system and how their access is controlled. In Lesson 5, I'll discuss processes, which are the running programs on the system. The Linux kernel controls the execution of programs, but the administrator influences processes through signals and kernel configuration. We'll learn how to use strace and the /proc file system to fully understand the internals of a process. In Linux, the motto is, everything is a file. In Lesson 6, we'll explore the Linux file hierarchy. We'll discuss the various types of files and their attributes, as well as controlling access to files using permissions and access control lists. Lesson 7 focuses on log files, which are the first source of information that an administrator should turn to when diagnosing a problem. We'll discuss where log files are kept and how they're collected. In Lesson 8, I'll demonstrate how to configure a Linux system for the network. We'll review both current and deprecated tools since they're both in common use. We'll also discuss how to configure DNS, the domain name service, and how to troubleshoot network problems. You should understand the basics of TCP/IP networking before viewing this lesson. Lesson 9 is about security on Linux systems. We'll discuss some of the steps an administrator should take to secure a freshly installed Linux system. We'll explore some tools for managing Linux system security, such as the Secure Shell and the iptables Linux firewall. By the end of this video series, you'll be equipped to begin administering Linux systems yourself. I hope you enjoy the videos as much as I've enjoyed putting them together. Welcome to Lesson 1, Where to Start. In this lesson, I introduce the role and duties of a Linux system administrator in a professional context. I tell you what knowledge might be useful to you before watching this video series. After briefly covering the history of Linux for context, I introduce you to Vagrant and VirtualBox, which you can use to set up a Linux lab environment for practice and testing. Finally, I point you to additional sources of documentation and information about Linux, and I discuss Linux tools that help you install software. Welcome to Lesson 1.1, Understand the Duties of a System Administrator. In this first lesson, we're going to understand exactly what a system administrator functions in an organization. We're also going to understand where a system administrator fits in the greater ecosystem of an IT organization. One of the first responsibilities of a system administrator is provisioning new user accounts. Those accounts might exist on a Linux system itself or on applications that run within a Linux system. What I have on the screen here is an example of a command. You'll notice a hash mark or a pound sign on the first two lines of the command. This simply indicates that it's a comment. The next line shows a $, indicating that this is a shell command that you can run in the terminal. In this example command, we're adding a new user. This user's name is bwhaley, and the user ID is 1001. The user has a home directory of /home/bwhaley and a shell of /bin/bash. This is the type of command that you might use when provisioning a new account. Another responsibility of a system administrator is adding and removing hardware from the system. This might be new disks, storage devices, network devices, or other peripherals attached to a Linux system. This example command shows the partition table for any disk attached to the system. Sudo fdisk-l is how you might pronounce this particular command. Performing backups is a critical responsibility of a system administrator. In the event that data is lost due to some catastrophic failure, such as crash of a hard disk or a data center flood or a similar disaster, backups and restores are an essential function. Here's an example command of creating a compressed archive backup of a specific path on disk. This is a very common way to compress and archive a large amount of files on the file system using tar. Installing and upgrading software is another common task of system administration. You'll need to release new packages, update the system for security vulnerabilities, or install new software as requested by users. This example command, which we'll learn more about, updates all of the packages on a Red Hat type of Linux system. One responsibility you'll have is to monitor the system to ensure that it's performing and at an acceptable level for users. Top is one command used to monitor the system. It shows CPU statistics, memory usage, and how processors are using the system. Monitoring is a deep and complex, involved task and often involves many systems collaborating in order to collect data. Troubleshooting problems is a common task that you'll find in day-to-day administration. You'll use various network utilities and system utilities to identify bottlenecks in the system and problems that might occur as you are going about your daily system administration duties. The example command I've chosen for the troubleshooting step is tcpdump. tcpdump is packet capture software used to capture network statistics. In this particular command, we're showing all TCP packets on the HTTP web port, which is commonly used as port 80, and also showing UDP packets on port 53, which is used for DNS traffic. As a system administrator, you'll need to maintain site documentation in order to educate other people on your team and throughout the organization about how you've set up the system. The documentation might take the form of wiki pages, of Word or Google documents, web pages, or whatever your team agrees is the best way to keep system stakeholders and yourself informed about how the system operates. Remember, just because you set something up once doesn't mean you'll remember exactly how that was done 3 months down the road. You might need a reminder just for yourself. Maintaining site security is of absolute paramount importance. One security compromise can damage the reputation of a business permanently. A system administrator is in a key position to ensure that the data is kept confidential, is kept with high integrity, and is kept available and up for users to use at all times. There are many tools and entire professions dedicated to keeping security intact. This is one example Linux command of doing what's known as a port scan on the network. In this particular example, we're port scanning the example where the system www.example.com resides. All of the /24 network of this host will be scanned. We're also going to try to guess what the operating system is of the remote system. This is a common way to determine what your exposure is on the network and how an attacker might leverage the network to gain a foothold. And of course, the daily site operational duties will consume a lot of your time as a system administrator. You'll field requests from incoming users, need to firefight problems, and use all of the tactics in the previous slide to understand exactly how your site is being operated. You'll have to communicate with many interested parties around the organization and ensure that you're meeting the organization's goals. As a system administrator, you'll interface with lots of other people on your team. Here's a few of the types of people that you'll be working with in your day-to-day system administration duties. One is administrators of other operating systems. This might be Windows administrators, or Unix administrators, or Mac administrators. You'll also be interfacing with network administrators. A network administrator's duty is to ensure that the network is configured correctly for systems to run on. They're the people that manage routers, switches, and connections to internet service providers. You'll be working with DBAs, also known as database administrators. These individuals maintain the persistent stores on the network, things like Oracle databases, or MySQL or Postgres, or other persistent data stores. Application developers are a key stakeholder for your system. They are the people that write the code that run the sites running on the Linux system. You'll definitely interface with site reliability and NOC engineers. These individuals have a primary focus of keeping the site up and available at all times. They often sit in a dedicated room with monitors mounted on the wall and watch the monitors for any delays or problems in the site operation. You'll work with and interface with security ops, also known as SecOps. These people use security tools to maintain and ensure the security of the data on the network. You'll need to work with these individuals to install new tools and to make sure that the tools are meeting their needs. You'll interface with storage administrators, whose primary goal is maintaining SAN and NAS and other remote storage devices and mass storage devices as they reside on the network. Finally, you'll also work with data center technicians. These individuals receive new hardware as it's unboxed and mounted in racks and cabled throughout the data center. Maintain a tight relationship with all of the different individuals in this slide, and you'll ensure the success of your IT organization as a whole. There's some background you should have as you start approaching the various videos in this lesson. We're going to go through some of the experience and background you should have that will prepare you for success. On the command line, you should understand a few different things about using the command line. First, you should have some familiarity with using any kind of a text terminal. This could be the Terminal app on your Mac, it could be a DOS prompt on Windows, or maybe you've already used a Linux system before, in which case you've almost certainly seen a Linux command line. You should also know some really basic commands about moving around the system on the command line. This could be changing or creating new directories. Maybe you know how to download files. You should just have some experience with running commands. Some basic programming logic will also help you here. You should understand conditionals, like if statements or case statements. You should understand loops, such as for loops and while loops. You should understand variables and how to assign them. It doesn't really matter what language you know, as long as you have some familiarity with how programming languages work. You should conceptually understand some things about operating system. you should understand what a kernel is and what its role is in managing CPU, memory, and input-output devices. You should know that the kernel is responsible for handling device drivers as the interface between the user and the hardware. You should understand that the kernel has a scheduler that allows processes to have a certain amount of CPU time. You should understand that the kernel also assigns memory to processes as they start up and stop on the system. You should know that the kernel mounts and unmounts and manages file systems, which are on devices attached to computers. You should know that the kernel manages the network stack. It is responsible for communicating with the network and is your interface to other systems. Linux is a monolithic kernel. The definition of a monolithic kernel is one single program that contains all of the code necessary to perform every kernel-related task. Now, strictly speaking, very few operating systems are entirely monolithic. Usually things are broken up a little bit. But as a whole, Linux is certainly considered a monolithic kernel. If these concepts don't make sense to you, make sure you go back and learn about kernel and operating system basics. You should have some background in TCP/IP networking. You should know what protocols are part of the IP protocol suite, such as IP, TCP, UDP, and ICMP. You should understand some terms associated with those protocols. You should understand what dotted quad notation is. When you read an IP address such as 10.0.0.1, you should know what that means. You should understand the CIDR network notation format. You might also need to know what a subnet is and what a route is and how that is important on a Linux system. You should understand at a high level what the purpose of DNS is. Now, DNS is a really complex system and you don't need to understand all of the ins and outs of it, but you should understand some basics such as what a hostname is, what a DNS record is, what a DNS server's purpose is, and what a reverse DNS lookup is. So if you don't understand some things about TCP/IP networking, read an introduction on TCP because it will be useful throughout this series. In this section, we're going to explain what the history of Linux has been and how we got to where we are today. It's nice to have some background on the operating system so you understand some of the quirks and eccentricities of how it works. We're using this Prezi presentation as a format to show this in its geographical context. The story begins in Finland, in Helsinki in particular. In 1991, Linus Torvalds, a student at the University of Helsinki, started tinkering with an IBM x86 compatible computer. He had just started using the Minix operating system, which is a microkernel and is meant for educational purposes, but is not open in nature. Linus wanted something that he could tinker with and use himself, so he started building his own kernel and his own operating system. Eventually, it got mature enough to where he decided to announce it, and he put it up on a Usenet post. In his initial post, he claimed that Linux would never be big and professional like GNU Hurd, which was sort of a competing operating system that eventually turned out to be vaporware and never quite came to life. In any case, lots of volunteers and community contributors around the world quickly started adapting and adding features to Linux. That's where it got its start and started to take off. Fast forward a couple of years to 1993 at Minnesota State University in Moorhead. Patrick Volkerding developed and released Slackware, which is one of the first Linux distributions. A Linux distribution is a package of software that makes an operating system. Linux itself is just a kernel, just the core of the system that manages the hardware and the scheduling and the things that we talked about in one of the last sections. But there's a lot more than just that to make an operating system work. You need a shell to manage commands. You need software to run on that system. You need things to edit text files. In general, there's lots of software that needs to be working in coordination in order for an operating system to work. And in Linux, an entire operating system is pulled together into what's called a distribution. Patrick Volkerding wrote Slackware, which is one of the first and most long-lived distributions. It's still managed and maintained today. Fast forward to North Carolina in 1995. By now, Linux is starting to make inroads with tech enthusiasts, although it's not yet really popular among businesses and enterprises. The first Linux Expo was organized by Donnie Barnes at North Carolina State University. The entry fee, $4. Mark Ewing was present at this expo. He later went on to start Red Hat, which is today one of the most popular and widely used distributions in enterprises. Now we move to Silicon Valley in 1997. Linus Torvalds moved from Finland to Silicon Valley to work for Transmeta, which is a CPU manufacturer. By now, Linux version 2 is released. It contains a number of advanced features needed by networks and used by businesses. In addition, many major distributions are starting to form and gain a larger user base. Popular distributions that people use today, such as SUSE, Red Hat, and Debian Linux, are gaining momentum. Now we move to Oregon in 2003. Torvalds has now moved from Silicon Valley to join open source development labs and is paid to work on Linux full-time. Linus's role now is as a kernel maintainer. He accepts code from many other contributors around the world, merges that code into the mainline kernel, and ensures that everything is operating and building smoothly. Enterprise use of Linux is accelerating and really is widespread at this point. The desktop environment for Linux, in particular the desktops GNOME and KDE, are ubiquitous. If you are a desktop Linux user, meaning you have it installed on your desktop at home or on your laptop or even on a tablet, though those weren't popular yet by this time, you're most likely using the GNOME and KDE window-managed environments. By 2007, of course, the Linux story has already been widely told. The Open Handset Alliance, of which, of course, Google is a large contributor, unveils Android as a Linux-based operating system for mobile devices, cementing Linux's place in the embedded systems market. In addition, the One Laptop Per Child project aims to ship low-priced Linux laptops to children in developing countries. The target price for these Linux laptops is around $100, though at this point it still hasn't made it past $200. So that brings us to Linux today in 2013. Linux-based web servers today account for nearly 75% of market share. The most common Linux servers in use are Nginx, a very fast and efficient web server, and Apache HTTPD, which has been around since the 90s. Valve Software, a gaming company, released its Steam gaming platform for Linux this year. The stable version of the Linux kernel at this point is version 3.10 and supports dozens of CPU architectures. Linux is on the bleeding edge when it comes to new operating system technology and new networking support. It is also a leader for jobs. 93% of surveyed businesses are said to be hiring Linux professionals, and sysadmins are the most sought after in this space. This is according to a job report from the Linux Foundation just this year. Hopefully this section gave you some context about how Linux got to where it is today and why it's absolutely imperative to the success of the internet. In this section, we're going to start actually practicing using Linux. I want us to set up a lab environment that we can use throughout the rest of the lesson to refer to the sections that I'm about to talk about. So, to get the lab environment set up, there's a few choices we have to make. First, we need to pick a distribution to use. As we learned in the History of Linux section, there's a variety of distributions that have gained popularity. First, there's the Red Hat family, which is composed of Red Hat Enterprise Linux, Fedora, and CentOS. Red Hat Enterprise is used by many large enterprises, is paid for with support, and is often a very stable distribution choice. Fedora Linux is the free version of Red Hat, often containing more bleeding-edge software, but is not supported. CentOS is a binary-compatible exact replica of Red Hat Enterprise Linux. It is not supported, but it has all of the features of Red Hat Enterprise. Next, we move on to the Debian family. Debian, Ubuntu, and Mint Linux. These have different package managers and other slightly different standards of how the distribution is used. They're extremely popular among desktop users and even among enterprises. OpenSUSE is a European-based distribution run by Novell. Next up, there's Arch and Gentoo Linux. These are meant for power users. Arch Linux lets you customize your system to your heart's content. Gentoo Linux builds everything from scratch and it's compiled precisely for your system. To get started, I recommend the use of Ubuntu or Fedora or one of the Red Hat or Debian family Linuxes. For most of this lesson, we're going to be using CentOS as our distribution of choice. We also need to choose a terminal emulator. I'll just put it out there that I'm highly biased in favor of Mac systems for Linux administration. In particular, I like iTerm2 as my favorite Linux terminal emulator. It's highly customizable, it has all the features that I need, it has tab support and multi-window support. You should download it, and you should use it, and you should contribute if you like it. Mac also comes with the Terminal app, built into Mac OS X. It's an okay terminal emulator. I used it when I started using Macs, but I quickly switched to iTerm2 as soon as I found out about it. If you're unfortunate enough to have to use a Windows system, I recommend using PuTTY, which is widely accepted as the most common freely available terminal emulator for Windows. I find it hard to use PuTTY without some of the additional add-ons such as Kitty and PuTTY Tray to just make it a little more powerful. Another terminal emulator is called Terminator and has some advanced support, much like iTerm2 does. If you are up for paying for a terminal emulator, SecureCRT is an excellent choice for Windows systems supporting session management and multiple tabs. So, now that we've made some decisions about what we're going to use, we need to download and install some software to set up our lab environment. There are two pieces of software that we're going to rely on. One is VirtualBox, which is free virtual machine software from Oracle. VirtualBox lets us run a virtual Linux instance within our system, so we don't even need a connection to the internet in order to play with Linux. We're also going to be using Vagrant, which is open source software that gives us really nice, clean, simple virtual machine management. Once you start using Vagrant, you'll see the power of spinning up and stopping virtual machines at your heart's content. Find lots of boxes or virtual machine images for Vagrant at vagrantbox.es. You can see in the example command here that starting up or initializing a Vagrant box is as simple as just running a single command, vagrant init, and then you specify a box name and a URL. So let's see an example. We'll start by making a new directory to hold our Vagrant boxes. Make dir vagrant. Now I'll change to that directory with the cd command. To get started with a new virtual machine, it's as simple as initializing a new box. Vagrant init, and I'll just come up with a new box name, CentOS. And then I need to paste in the URL of a Vagrant box. I'll switch to a browser window, and I'll visit www.vagrantbox.es. There's a large variety of boxes and distributions to choose from here. And I'll just pick one of these CentOS boxes. Paste in the URL. Vagrant creates a new file called a Vagrant file. We don't need to go through every line in the Vagrant file, but we can look at some of the contents. All it really does is specify that I want to start a new box called CentOS and where to find the box if it's not already loaded. In order to start, I can just say Vagrant up. If the machine doesn't already exist, Vagrant automatically goes out to the website, begins downloading the box. We'll skip the download here. Once the download is complete, Vagrant will proceed by starting up the virtual machine in VirtualBox. You'll never even need to see a VirtualBox window as it's handled behind the scenes by Vagrant. At this point, since the operating system has finished downloading, I'm just booting up the virtual machine. It will only take a minute. Once the virtual machine is booted, it shares some files so that you have access to your Mac system as well, and it makes the Linux system available for you. Now that Vagrant up has finished running, I can run Vagrant status to show me the status of the box. In my case, I have two Vagrant images running, a CentOS box and an Ubuntu box. If I want to log into one of my new Linux boxes, I can type Vagrant SSH and then the name of the box, which I'll copy and paste. It'll be the CentOS box to start with. You can see that it's logged me into Linux and it greets me with a message. At this point, I'm on a Linux system and I am no longer running on my Mac. I can exit back to my Mac by typing Ctrl-D or exit. To halt my virtual machines, I can say vagrant halt. This will stop the virtual machines, but will not remove them from the system. It only takes a minute. Feel free to start, stop, destroy, or initialize new boxes as needed. These boxes are all temporary. You can use them for development purposes, for testing new software or features, or for whatever purpose you see fit. In order to list the boxes I've already imported, I can type vagrant box list. This shows me several boxes. I have a CentOS box, an Ubuntu Precise 64 box, which is a specific release of Ubuntu Linux, and a Raring box, which is also a specific release of Ubuntu. In order to initialize one of these machines I've already imported, I can type vagrant init and then the name of a box, such as Precise 64. This creates a vagrant file just as it did in the previous example. I can now type vagrant up. It will import this box. In other words, it will make a copy of this box and import it into this directory and then boot the virtual machine. It's never been easier to get started with Linux than using VirtualBox and Vagrant. There'll be many times during your administration work and duties that you'll need to refer to documentation. Google is always your friend when it comes to using and learning about Linux. However, there are other sources that you can turn to specifically for deeper questions or if you need a quick answer. The traditional way to learn about Linux and Unix systems is through man pages. The man command formats and displays online man pages on your Linux system. It usually comes in a variety of formats. In particular, these sections are almost always present in a man page. The name displays, of course, the name of the command that you're looking up, as well as a succinct, really concise description of what it does. A synopsis is a little more detail about how the command is run, including what arguments or options are passed to alter the command's purpose. The description field goes into detail about what the command is, what its functionality is, and what it's meant to accomplish. The general options section goes into detail about all of the arguments and flags available to the command. There are often several examples presented of how to use the command and what files are associated with that command. The See Also section will refer you to similar commands, and authors is just what it sounds like. It's whoever wrote the utility. So let's look at an example man page. The Mac terminal is a Unix system, and so it has man pages available to it. However, we're going to go ahead and log into one of our Vagrant Linux boxes and take a look at the man page there. Now that the box is booted, I can type vagrant SSH in the name of the box that I want to log into. This is only necessary when you have more than one box running, such as in my environment where I have a CentOS box and an Ubuntu box. Now we can type man and the name of a man page that we'd like to look at, for instance, SSH. The top of it, this should match very closely what we saw in the slide. We have the name of our command, a synopsis of all of the options available to that command, a description of the command and its options. I page through the man page with the spacebar. We can see that SSH has lots of options. We can also see that there are some high-level sections that are command-specific. For instance, we have escape characters and TCP forwarding as being specific to the SSH command. We see the See Also section, which refers us to lots more information about SSH, and we see an authors section. This is a very typical man page, and I usually use it to quickly refer to a command syntax. It's even faster than using Google. In addition to the online man pages, there's lots of places online on the web to learn about Linux. Some of the sites I like include linuxquestions.org, which is a great forum-style communication tool, Ubuntu Forums, which is somewhat Ubuntu specific, but has lots of generally relevant information. JustLinux.com, which, similar to Linux Question, has lots of active forum members and a thriving community of Linux users. And of course, my favorite, the go-to lwn.net, which provides detailed coverage of Linux, the open source community, the kernel development process, and is run by a really great group of active Linux developers. If you need real-time support for Linux or the software running on Linux, you can turn to IRC, and in particular the Freenode network. Freenode has been established as a common chat and communications channel for all sorts of different software, Linux included. So when you need real-time support from friendly people, log into IRC. In this lesson, we'll learn about how to find and install software on a Linux system. Now, we should keep in mind that software and packaging is a very broad topic. There are people who dedicate their entire career to making sure that software is easy to download and access and install. So our coverage here is really just to get you familiar with what's available. So first, we should understand the concept of a software repository. A repository is a collection of software packages, often for a given operating system or even for a given CPU architecture, like a 32-bit processor versus a 64-bit processor. On Linux systems, the most common packaging systems are RPM and Deb. Red Hat systems use the RPM format, and Debian systems use the Deb format. RPM packages are usually installed and managed with a program called Yum. Debian packages, known as .deb files, are usually managed with a system called apt. These systems allow you to search the internet and the software repositories that host packages to install new software on your system. There's lots and lots of software available. You'll often need to use these repositories not only to install new software packages, but also to update your system in the event that there's a security vulnerability with one of the existing software packages. This is, in fact, very common. New security vulnerabilities are found in packages almost every single day. In addition to these common Linux package management repositories, there's more software available in the format of Ruby gems, Python packages, and Perl modules. There are many sources for various scripting languages that are specific to programming languages. A Ruby gem is a gem file for Ruby that includes libraries or applications written in the Ruby language. It is managed with the gem command. Python packages are usually installed and managed with a tool called pip. Pip searches Python package repositories for new Python packages. CPAN, known as the Comprehensive Perl Archive Network, is a collection of libraries and tools available for Perl. GitHub is a very popular repository for collaborative open source software development. You'll find projects large and small on GitHub. You can create your own projects on GitHub and easily share it with other developers. It's a common way to access bleeding edge or new software. SourceForge.net is more commonly used for downloading binary files. GitHub is often used for source code, while SourceForge.net contains various software that's in binary format ready to use. And of course, sometimes you might need to compile software from source. This means downloading the source code from the internet and using Linux to build that software using a compiler. We won't cover that here, but we will talk about using Yum. I'm already logged into my Linux Vagrant box. I can use the Yum command to search for a specific package. For example, I could use Yum to search for the Linux kernel itself, using Yum search Linux. This command connects out to the software repositories configured on my CentOS system and searches available packages that might contain the keyword Linux. You can see that there are a lot of hits. I can use RPM -QI kernel to show what packages that are the Linux kernel installed. I can use RPM -QA, pipe it to grep for Linux, to show all of the packages installed on my system that contain Linux in the package name. Don't worry if you don't fully understand this syntax, we'll learn more about it in a later lesson. Just know that when you need to install packages, yum and rpm on a CentOS system, or apt on a Debian system, are your most common commands. Welcome to Lesson 2, the shell. In this lesson, I cover the purpose of a Linux shell before going right into demonstrations and examples of using the shell. You learn what a regular expression is and how it's useful as an administrator. I introduced Vim, which is a powerful and versatile text editor that you can use to edit files and write code. I go over a basic shell script so you can see the utility of automation. I also provide pointers to powerful, full-featured programming languages used frequently by administrators. One of the best places to start learning Linux is by learning the shell. Learning the shell in detail will help you become a more efficient and effective system administrator, so it's important to spend a lot of time on this concept. So what is the shell? The shell is an interpreter. It takes commands from the user and executes them on the system on the user's behalf. Importantly, the terminal is not the same as the shell. Your terminal, like we talked about before, being perhaps iterm or secure CRT or PuTTY, depending on which system you use, is just a window to the shell system. The shell is an executable that interfaces directly with Linux. It is a command line interface, unlike a graphical interface or a graphical user interface, a GUI, that you might be familiar with on Windows or Mac. It has a long and sordid history, with various shells being claimed as the best shell or the worst shell, depending on who you ask. The SH, or the Bourne shell, is a very common and basic shell written at AT&T, and then there's a competing shell known as CSH, written at UC Berkeley, originally for Unix. Today, the usual default on a Linux system is Bash. Bash is highly powerful and is shipped as the default on nearly every Linux distribution. In addition to Bash, there's a very committed fan base among power users for the shell ZSH. It's backward compatible with Bash, but it extends it and adds additional features. Some eccentric types of sysadministrators might use TCSH, or some administrators with an IBM AIX Unix background might be used to the Korn shell KSH. Any of these shells will help you accomplish your system administration duties, but for convenience, I recommend sticking with Bash, the Born Again shell. That's what we'll spend all of our time in this lesson covering. It's super important to understand the shell. The shell is your window to the system. Most of your administrative time on a Linux system is spent on the terminal typing shell commands. It's also useful in the form of automation through scripts. The shell can be used as a programming language to automate system administration tasks. In fact, it is commonly used to do just that. So, with that said, let's get started using the shell. In this section, we're going to explore the basics of using the shell. You'll learn how to move around the command line effectively and efficiently. We'll also use a text editor, VI, which you'll spend a lot of time in as an administrator, and we'll write a basic shell script. So let's get started directly on the shell. First, we need to learn how to move around the file system. You want to learn to list files with the ls command. ls lists the files in your current directory. To make a new directory, you type makedir and then the name of your directory. You can change into that directory with the cd command, change directory. We will cover the file system in more detail in a later lesson, but you should know that it's a hierarchical structure. If I type the pwd command, it shows me where I am in the hierarchy. The shortcut dot, just a single period, refers to the current directory, in this case /home, /vagrant, /neudir. The shortcut dot dot refers to the parent directory, or in this case /home, /vagrant. So in order to move to the parent directory, I type cd dot dot. If I type ls again, I see the files I saw initially as well as my new directory. I can type to a new path, cd space /temp, and in order to go back to my home directory, I have a number of options. I can type cd, which is just a shortcut to take you to your home directory. You can type cd tilde, which is also the shortcut to the current user's home directory, or I could type cd minus, which takes you to the last directory you were in. Let's look at the shell prompt itself. We have the username, in this case Vagrant, and we have the host name. In this case, the host name is localhost. This will vary depending on the system you're in. The next section is the directory you're currently in. Tilde represents the user's home directory, and notice that when I was in temp, shell prompt showed temp instead of tilde. So the prompt changes as you move about the file system. The bash shell prompt is highly configurable, and people like to make all sorts of adjustments to suit their needs. Let's learn about how to edit some commands. On the bash shell prompt, the hash character indicates a comment. The $sign at the end of the prompt indicates that I'm a regular user ready to type commands. By convention, when you become the root user, which is a highly privileged user in Linux, the prompt changes to a hash sign to indicate that you're root and you should be more careful. We'll learn more about user privileges in a later lesson. In general, you should always log into the system with your normal account, and if you need to execute privileged commands, use the sudo keyword. We can run a command just by typing it, and of course if we want to run multiple commands, we can separate them with a semicolon. For instance, we could list files, and then we could change directories in a single line. Notice that the files listed out, and then my directory changes changed. I can go back with cd minus. I can put a process in the background with the ampersand character. For instance, I could open Vim, a text editor, but I could put it in the background so it's running not in my current context. So in this case, Vim opened, it's running with process ID 1762, but we're still in the shell. We'll learn more about how to control processes and what a process ID is later. If I wish to now access the program that I started in the background, I can type FG for foreground. Now I'm in the Vim text editor. We're going to cover Vim in just a few minutes. Something that will really help you become an efficient system administrator is using shortcuts on the command line. Let's learn a few shortcuts that will help us move around the command line quickly. We can use the echo command to echo output to the terminal. For instance, echo, the quick fox jumps over the lazy dog. This just echoes that output to the screen. Now if I hit the up arrow, I can recall that previous command. I can use Alt-B to move back a word, and I can use Alt-F to move forward words. You can use Control-A to quickly move to the beginning of the line. You can use Control-E to quickly move to the end of the line. If I use Control-U, it erases all of the text that I just typed and puts it in my paste board. I can paste it back with Control-Y. We'll have a handy list of shortcuts for reference available with the lesson materials. Now we're going to learn about a concept that is essential to understand for a Linux or a Unix system administrator, and that's pipes and redirection. Pipes and redirection is a concept that has given the Linux command line some of its most powerful features. So, for example, the ps command shows us the running processes on the system. I can pass it some arguments like ps ax to list processes in more detail. Don't worry if you don't understand the ps command, its arguments, or the output. That's not the focus here. If I type ps aux and I use a greater than symbol, that will take the text output from the ps command and it'll redirect it. So for instance, I could redirect it to a new file called processes. Now the content from that command has been captured in this file called processes. I can see the type of file that it is by typing simply the file command and giving it whichever file I want as its input. For instance, file processes shows me that it's just ASCII text. Now I can search within that file and I could perform operations on the text within that file. For instance, I can use the grep command and search for a specific keyword within the processes file. In this case, it found that there was a process in the list called bash within that text file. We're going to learn about grep and its purpose in a little more detail later on. You should also be aware that you can use tab completion on the command line. So when I start typing something, for instance gr for grep, I can hit tab and it completes other possible commands for me. If there's only a single option, it will finish it completely. For instance, if I continue to type grep bash and I type pr for processes, if I hit tab, it automatically expands the file name. This will save you a lot of typing. Now comes piping. Piping allows you to string a series of commands together using the output from one command as the input to the next command. For example, I can use the same command we did before, psaux, and then the pipe key, which is the vertical bar usually situated above the return key, and I can pipe it to grep for some specific command like bash. So this is running the process list and searching for very specific output. Using the pipe, you can connect any two commands together, or you can string many pipes together to perform very complex operations. For instance, I could echo a brief statement in quotes, and I could use greater than to append it to the processes file I already captured. Now if I use the tail command to look at just the end of the processes file, I can see a brief statement as the final line of input. Next, let's learn about variables and quoting variables. To assign something to a variable, you simply type the name of a variable, the equal sign, and then whatever you want that variable to contain. For instance, I'll assign the quick brown fox to the text variable. I can view the variable contents with the echo command. Now, importantly, I can also capture the output of a command into a variable. For instance, if my variable name is ls_text, I can capture the contents of an ls command into that variable using this syntax. So let's just make sure we understand this. LSText is the name of the variable. Equal sign indicates that we would wish to assign some contents to it. And then we have $ with an open and closed parenthesis and the command in between them. This will take the output from ls-l and assign it to the LSText variable. Now look what happens when I try to echo the contents of this variable. It's the same contents that we would expect from the ls-l command, but it's all glued together with no line breaks. This is due to how the shell has interpreted this variable. If I instead use double quotes to echo the output of this command, I get the exact format that I expect. Now note that if I use single quotes rather than double quotes, I get the literal LSText variable output. So quotes are important to the shell. When you use a single quote, the variables are not interpolated by the shell. When you use a double quote, the variables are interpolated by the shell. We should also distinguish between environment variables and regular variables. An environment variable is available to all processes on the system. You can use the command printenv to view all environment variables. We see several environment variables here that are set automatically by the system. You can use the export command to make shell variables available to sub-processes on the system. For instance, in order to capture an environment variable, we type export and then the name of the variable. By convention, environment variables are always uppercase. So if we wanted to export LSText, we would probably name it uppercase, and we could use the same command we used before. Now the LSText variable is available to any sub-processes that I start with in my shell. To remove a variable you've already created, you can use the unset command. You type unset and the name of the variable without the $, and then that variable is removed. If you try to echo it, it has no contents. Next up is learning about filtering. Linux has a powerful variety of filtering commands available at your disposal. We'll use the cat command to cat out the etc passwd file. This file contains all of the user accounts on the system. We don't need to parse through each line of the file now, but we should just note that each field is separated, otherwise known as delimited, by a colon. The first field is the username, the last field is the shell, Just for example, we don't need to go through each field, but look at how we can manipulate this file using filtering commands. I can use the command cut to pick out specific fields in the output. For instance, if I wanted just the username field, I can use cut -F1 -D, and then in single quotes a colon, and then I pass the name of the file to print out only the first field of the file. So just to make sure we're clear, -F is the field, we want the first field, -D is the delimiter, in this case the colon. You can learn about all of the arguments and flags available to the various commands using the man pages. We can continue to use pipes and redirection to add on to this command. For instance, I can repeat the previous command by pressing the up arrow. I can use the pipe character to pipe this output into the sort command. Now the output is sorted alphabetically. I can continue this by adding another pipe and piping it to unique. Unique will remove any duplicates that are in the output. In this case, it actually didn't do much since there were no duplicates. Finally, I could pipe the output yet again to filter out for just, say, the first 5 results. I could do that with pipe to head -5. Now we're only printing out the first 5. Similarly, I can use tail -5 to print out just the last 5. Filtering commands are very powerful and you'll find yourself using them regularly. Next, we can look at shell history. Shell history will help you recall previous commands that you've already typed on the terminal. It becomes very useful because you'll find that commands are often repetitive. History is stored in your home directory in the file .bash history, which we'll look at right now with the less command. This shows all of the commands that I've typed on this terminal. I use Q to quit out of the less command. You can access the shell history interactively in the terminal with the up arrow and the down arrow. Notice as I push up and down, I parse through the commands that we've already been typing. You can type the history command to quickly, at a glimpse, see all of your shell command history. We notice that there is a number in advance of each command. This lets me quickly access a command in my history. For instance, if I wanted to access the file processes command in my history quickly, I could use exclamation point, often called just simply a bang, and then the number, 499. That runs the same command again. I'd like to encourage you to become familiar with the Control-R search history function of the bash shell. If you type Control-R, your prompt changes and it says reverse I search. What this means is that it's going to search in your history for case-insensitive content of whatever you type. Let's go back and type fox. We see when in the past I assigned text equal the quick brown fox in the variable assignment example. If I hit Control-R again, it continues to search in my history. This is a really quick and efficient way to access your shell command history. Now if I just press enter, it executes that command again. If you become proficient at using Control-R, you'll find that moving around the bash shell is very quick and efficient. I can execute the last command that I just typed with the bang bang shortcut. I can also refer to just the last argument on the command line. For example, if I type ls-l processes, that shows me a long detailed listing of the processes file. Now I can, as a shortcut, type file and then bang $sign to refer to the last argument on the previous command. This runs the command file processes. I hope that this brief introduction to Linux hotkeys was useful for you. Next, we're going to learn about regular expressions and shell globbing. Regular expressions are a language used to parse strings to pull out specific content. System administrators and developers alike use regular expressions in their everyday lives. First, some definitions. A string literal is any character that we use in a search or a matching expression. For example, to find the NUX in the word Linux, the NUX is a literal string. It is literally the string we wish to find. A meta character is one or more special characters that has a unique meaning and is not used as a literal in the search expression. For instance, consider the caret character, which is the Shift-6 key on your keyboard. This is a meta character that matches the very beginning of the line. Next, the search expression, also known as the regular expression. This is the expression that we will be using to search in our target, or in other words, it's a pattern that we use to find what we want to find. Consider, for example, the string bwhaley@gmail.com, my email address. The search expression caret bwhaley@ followed by .* matches any line beginning with bwhaley@ followed by any character at all. So if we wanted to find bwhaley@gmail.com in a text file, and where bwhaley starts the line, this is the search expression you could use. An escape sequence, or just an escape character, indicates that we wish to treat a meta character as a literal. So this is a little confusing, bear with me. Consider the case of the word persons, where the S is in parentheses, meaning it would be person or persons, plural. If we wanted to find just the S in the target string, we need to escape the parentheses since they're also regular expression meta characters. The search expression becomes then \, open parenthesis, S \, close parenthesis. And in this case, the \ character is the escape sequence. Let's look at an example on the command line. I'm already logged in directly to my Vagrant Linux box. I can use the egrep command to search within the etc passwd file, which is the same file we used before when we were learning about how to filter commands on the command line. In this example, we're using egrep, the Extended General Regular Expression Parser. Actually, grep comes with many definitions. That's the one I chose here. In this case, we're matching any of the characters W, Y, or Z as they appear in the etc passwd file. Note that all of these lines contain at least one of those characters, but it doesn't mean that those characters are all in a row. It just means that the line has to contain the character somewhere. Similarly, we can use some shortcuts like capital A through Z, which matches any uppercase character. In this example, the output shows every line contains at least one uppercase character. We can show an example where we need to match a certain number of occurrences of a character. Consider this example. We're using egrep to find X and then a colon, which as we can recall is a field separator, followed by 0 through 9 at least 3 times. We can see that in each of these lines of output, there are at least 3 digits in a row, and that these are all of the lines in the etc passwd file that match 3-digit user IDs. We can match the beginning or end of the line with the caret and $. For instance, if I use egrep *r and search in the etc passwd file, I find all the lines that begin with R. Similarly, I can match lines that end with H by using $. In this case, the results are all where the shell is bash for that given user. We can use the pipe character to separate words. For instance, we can search for either the word bash or the word false with a $, indicating it's at the end of the line. Note that all of the output we matched either ends with bash or with false, which is just a false shell. It doesn't do anything. We can combine these techniques to search for very specific things. For instance, if we wanted to search for the string starting with an R, continuing with any character, and ending with bash, we can use this syntax. *r $*bash$. The shell also supports a limited set of regular expressions, or regular expression-like language, known as shell globbing. The shell itself doesn't support a really large number of regular expressions, but you can do some subset of the command, such as ls*, which lists all of the files, and in this case a directory, nudir, in this directory. We can also move things around. For instance, if I wanted to move n*, which should match the nudir in this directory, to /temp, now I've moved the nudir to /temp. That's a brief introduction to shell globbing and regular expressions. If you familiarize yourself with regular expressions, you'll find it to be very convenient on the command line. To really become an effective system administrator, you must become proficient in using text editing. There are a number of text editors on the Linux platform. A few of the most popular ones include VI or Vim, related projects, Emacs, as well as Nano and Pico, which are simple text editors. I strongly recommend becoming familiar with Vim, which is the most popular among system administrators and can be found on virtually any Linux system you'll ever use. We're going to spend a few minutes learning Vim, since it can be a little confusing to somebody who hasn't used a modal text editor such as VI before. You'll find a file called Gettysburg Address, which contains the actual text of that speech. We can list it on the command line. To open the file in VI, we use VI or Vim, which is an enhanced version of VI, and then pass the file name. This opens the contents of the file. In a normal text editor, you might just start editing and deleting words and characters now, but that's not how VI works. VI is a modal text editor, and so in order to edit text, you need to be in the editing mode. The default mode, which you can always reach with the escape key, or called normal mode, lets you move around the file, but doesn't let you edit. In order to edit, you type I. Now look at the bottom of the screen and you'll notice the file name, Gettysburg Address, in quotes, followed by the number of lines and the number of characters. As soon as I press I, it changes to say that I'm in insert mode. This means I can start typing and editing text. To get back to normal mode, I hit escape. There's also command mode, which you reach with a colon. Notice when I type a colon, the bottom of the screen changes to a colon. Using command mode, I'm able to issue commands to the terminal. One useful command to know right away is how to quit. If you type colon followed by Q, enter, you quit the file. You need to know how to open and close files, so that's a critical one to keep in mind. Let's open it again. A final mode is visual mode. I type V to go in visual mode. Now I'm able to highlight lines, which I can use to copy and paste or make edits to the file. Hit escape to return to regular mode. Now we need to learn to move around. You can always move around with the cursor keys, the arrow keys in the bottom right part of your keyboard, but that's not the fastest way to move around in Vim. You can use H, J, K, and L, the keys on the home row of your keyboard, to move around. L goes right, H goes left, J goes down, and K goes up. You can move entire words at a time by typing W, or B to go back. You can type a $sign to go to the end of the line, or a 0 to go to the beginning of the line. Moving around with these hotkeys will make you a much faster and more effective text editor. I can search for a very specific letter on a line using the lowercase f. For example, on the second line, the word liberty starts with a capital L. If I type F capital L, I go to the first occurrence of the L, the capital L on the command line. Now in Vim, very commonly you can inverse the search with a capital. So for instance, the very beginning of this line starts with a lowercase a. In the word nation, there's also a lowercase a. So if I wanted to go to the a at the beginning, it's 2 a's over. In order to reach that, I will say 2, capital F to search backward, and then lowercase a. And it takes me to the first A on the line. This might sound cumbersome, but it's actually very effective once you become proficient at it. You'll recall that if we press I, we go into insert mode to begin typing characters. If I use capital I go to insert mode at the beginning of the line. I can also use A, lowercase a, to start appending to the text where my cursor currently is located, or I can use capital A to start typing at the end of the line. Sometimes you need to move your cursor around the file quickly, maybe even to specific lines. I can use the capital G for that. For instance, I can use capital G to go directly to the end of the line. I can type 2, capital G, to go to the second line in the file. If I have multiple pages of text, I can use Control F and Control B to page between the text. You'll also sometimes need to search within a file for something specific. And in order to search, you can use the / key. For instance, if I search for the word "and" in this file, I find several hits, and Vim highlights them for us. You can use the lowercase n key to switch between all of the hits, moving your cursor directly there. And if you use capital N, it searches backward. It's quite consistent. Next, we'll learn some basic editing with Vim. You can, of course, go into insert mode with a capital I and begin typing some text. You then hit escape to switch back out to command mode. Now, that's not necessarily the most efficient way to manage all text. You can use the X key to start deleting text. So if I'm on the B in begin, I can type X, and each time I type it, it deletes one character. If I decide I want to undo what I had just done, I can use the U key for undo. And if I use Control R, I can redo what I had just typed. I can delete entire words at a time by typing DW, or I can change a word, which means delete the word in front of my cursor and start inserting a new word. So for instance, if I'm on the S in the word score, I can type CW to delete the word score and type a new word. I can delete an entire line at a time using DD, or I can change a line using CC. If I need to open a new line, I can use lowercase o to open a new line below my cursor. Or if I need to open a line above my cursor, I can use capital O. I can also repeat the last command by simply typing the period. Finally, you can copy and paste in Vim using yanks. I can use YY to yank a line to my clipboard, and then I can paste it using P. I can paste it above my cursor using capital P. That's really the basics of using Vim. You can type :help in Vim to get to a help screen that will teach you how to move around and how to use the editor in more detail. It is a highly customizable and powerful editor, useful even for programmers who are power users and need to navigate around the file system. Let's quickly learn how to edit and use multiple files at a time. Now, I've made a bunch of changes to the Gettysburg Address, and I don't really want those reflected in history. So I'm going to quit without saving my changes. In order to do that, I use :q bang. Now, if I want to open multiple files, I can simply list them out on the command line, one argument at a time. In this case, I'll open 3 files: the Gettysburg Address, a script called postinstall.sh, and another script called passparser.sh, which we'll go through in detail in a later lesson. I now have 3 files open. In order to list the files, I can type :args, ARGS, which lists all of the arguments I passed to Vim. Notice at the bottom, it shows that I'm on the Gettysburg Address, indicating that that's the current file with square brackets, and that there are 2 additional files. I can type :next to go to the next file in the list. And I can type :prev to go to the previous file. Just as before, I can type :q to quit. We're going to take all of the knowledge we have from the previous lessons and formulate a bash script, just an automated way to execute multiple commands and perform some function. The script that we're going to use is one that I've written called passparser.sh. You would never use this script in the real world since it doesn't do anything particularly useful. However, it does demonstrate several features of bash that you'll commonly encounter when writing real scripts. Passparser.sh, all it does is read the /etc/passwd file, each line at a time, sort it by user ID, and print the output in a very specific format. You can refer to the man pages anytime you're confused about the syntax of any commands used within the script, but we're going to go through it line by line. So first, we want to check what the permissions on the script are. In order for a script to execute, it must have the executable bits set. We haven't learned about file permissions yet, but let's quickly look at the permissions on this file. If we run ls-l, we see a lot of output on this command line. In particular, we're interested in the beginning of the line. We see several RWX. This means that the file is readable, writable, and executable. The first 3 are for a user, the second 3 for a group, and the last 3, which doesn't have a W, is for everybody else who might use the system. We're going to go through that in detail later, but importantly, the X is turned on, meaning that this file is ready to execute. Now let's see what the output looks like. We'll remind ourselves first by looking at the raw etcpastwd file. Remember that it contains a list of users with a colon-separated field. If we run our script, which we preface with /, indicating that we wish to run the script within this directory, the thing that it does if we don't pass it any arguments is give us a usage statement. This is very common in Linux systems. The usage statement indicates what flags and arguments you need to pass to the script. This takes /etc/passwd as its only argument. What happens if I try to pass it two arguments, like etcpastwd and then the number 1? It also prints out the usage statement. So it's doing some smart things about checking the flags. So let's pass it what it's expecting, just the etcpastwd file. It prompts me, do you wish to parse etcpastwd? And then it indicates that I should type yes or no. I'm going to type something else, blah. It prompts me again, do you wish to parse etcpastwd? Yes, I wish to parse it this time. So we can see that it looked at the output of /etcpastwd and printed the output in a very specific format. It says that the user root has UID 0 and has home directory /root. Let's look at how it worked. I'm going to open the script with VI. We'll start at the top. The first line indicates that this script should be interpreted with the bash shell. The #bang, the # and then the exclamation point, is called a shebang. It just indicates that this is meant to be an interpreted script, and then the next section says the interpreter is bash. Here we're on the first conditional. This is what an if statement looks like in bash. It's doing the syntax check, the bit that says we need to make sure that we are accepting one argument. So we have an if statement, and then we have our 2 conditions. One condition is that the number of arguments passed must be exactly 1. If it's not equal to 1, then the test fails. Then we have an or, and then there's another condition. The first argument minus h. So if either one of these conditions is true, then we will follow the next 2 lines. We'll echo the usage statement, and we'll exit with exit code 1, which usually indicates an error. Next, we're reading the command line argument, which we pass, in this case etcpastwd, into a variable. The variable in this case is file. In bash, when you need to read a command line argument, it's always starting at $1. $0 indicates the shell file itself, the script itself. Next, we have a function. This is a reusable bit of code. We have an until loop. The purpose of this loop and this function is to determine when the answer is yes to the question, do you wish to parse the file? So until the answer variable contains either yes or no, this loop will just continually prompt, do you wish to parse the file? And then it will read the variable, and then it will test it again forever. Next, we have a conditional. If the answer was no, then we just exit. So if they don't wish to parse the file, then we'll exit. After that, the function just returns. Now we call the function using the parse prompt. So again, this isn't really how you would run a script in the real world. Most commonly, any code contained within a function will be called more than once. In this case, we're only calling it once for demonstration purposes. Finally, we get to the real meat of the script where the parsing happens. I always like to copy and paste an example of the line that I'm looking to parse, so I have it for a handy quick reference. So I've copied and pasted one of the lines from the etcpastwd file here. Next comes the looping logic that sorts and prints out the parsed lines to the terminal. First, we sort the file by its user ID, and then we loop through each line, matching the desired fields and printing the output. So first, we have an example of running a command and piping it to the loop. We use the sort command to sort the file by the third field. So the field separator is passed to sort using -t, and -k indicates that it's the third field, and -n is the file that we wish to parse. In this case, etcpasswd has been assigned to the file variable. We take the output of that sorted file and we pipe it to this while loop. The while statement reads each line at a time. The 3 lines starting with user followed by user ID and homedir parse the line. So we use the echo command to pipe the output to the cut command, which pulls out the first field. Next, we want the user ID, which, looking at our example line above, we can see is the third field, so we cut out the third field. Next up is the homedir. The homedir here is the 6th field, which you can count with those colon-delimited field separators. Once we have all 3 fields, we can echo that output to the terminal. Notice that we use $sign and then curly braces with the variable between them. This is a common way to use a variable in a script. Finally, just to demonstrate how a regular expression can work in Bash, we check that if a user ID contains at least 3 digits, then we print out this user has a UID with at least 3 digits. Finally, we close the loop with a done statement indicating that the loop is finished. So that's a simple Bash script. You'll find these all over Linux systems in order to automate and make more efficient many tasks. We've just learned all about the Bash shell and about writing a quick script using Bash. In reality, when a program gets a little more complex, we need to turn to another programming language, and there are many, many programming languages available at our disposal. We'll cover many of the common system administration languages used for quick scripts in this section. First up is Perl. Perl was written by Larry Wall, one of the leaders in the open source software movement. Perl was originally derived from the C programming language, as well as some shell programming concepts, the Lisp language, and the string parsing tools awk and sed. Perl's motto is, "There's more than one way to do it." Larry Wall is a linguist at heart and has built Perl based on the principles of natural language design. Perl is tried and true as a programming language and is used in many large websites and projects. It has CPAN, as we indicated before, the Comprehensive Perl Archive Network, including a huge base of modules. You can reuse those modules as libraries in your own programs, so you can avoid writing software that's already been written. There are many reasons to use Perl. A couple of them include extending, updating, or contributing to an existing large Perl project. Perl is also still a good choice as a portable, cross-platform language since it's available on nearly any Unix and Linux system around today. Python is another very common language.
It was created by the Dutch programmer Guido van Rossum, who, along with several others in the open source community, is known as the benevolent dictator for life.
This term is lovingly given to open source authors who maintain projects that are used by a large user base. Python differs from Perl in some important ways. In Perl, we talked about the saying, there's more than one way to do it. In Python, there's one, and usually only one, obvious way to do it. In Python, they also believe that beautiful is better than ugly, which is kind of a ding against the Perl syntax. In Python, indentation is meaningful and is intended to help with readability. So if you have a line and the line below it is indented by a few spaces, that means something in the Python language. Python has excellent object-oriented support. It's used in large-scale web applications and is great for sharing readable code among a large team. The final language we'll mention here is Ruby. Ruby was written by Japanese computer scientist Yukihiro Matsumoto. His stated goal with Ruby is that it intends to make programmers happy by focusing on creativity. In Ruby, everything is an object, just like as in Python, and there's more than one way to do it, just like as in Perl. Ruby is great for native integration with some of the really popular configuration management tools out there, such as Puppet and Chef. It has a very low learning curve, an obvious syntax, and is very simple to read. Many open source projects are coded in Ruby. Welcome to Lesson 3, Booting and Shutting Down. One of an administrator's basic responsibilities is to safely start up and shut down the system. After any major changes, an administrator should reboot the system to ensure it can survive a power outage or other unexpected crash. However, if something goes wrong during the boot process, you should know how to fix it. In this lesson, I discuss the bootstrapping process and the Linux bootloader grub. I point out how the kernel is loaded and begins execution. I talk about Upstart, the software used to manage processes on the system. I also cover init scripts, which are a legacy method of managing the startup and shutdown procedures.